All right, we're going to start this lab wrap-up by taking a look at the post-lab questions for the You Light Up My Life lab that we did last class. And hopefully you've already done number 1. If you haven't, here we go. Let's take a look at all of these 11 different substances and categorize them in this flow chart. So first off, we're going to start with the question of does it dissolve or not? So on the left-hand side, we have yes. And then as it dissolves, is it going to conduct electricity, yes or no? So the ones that do dissolve and can conduct electricity are going to be the NaCl, CuSO4, and CaCl2. And then we have the ones on that left-hand side that, again, do dissolve but do not conduct electricity. So that's water, the 2 sugars, C6H12O6, C12H22O11, and the other clear liquid we had over there, C3H8O, which was rubbing alcohol. And then on the right side of the chart, we have the ones that don't dissolve. So we have some that don't dissolve and still conduct, and those are our metals, aluminum and copper. And then we've also got the ones that don't dissolve and still don't conduct, and those are going to be our wax, the C20H42, and the sand, SiO2. All right, so once you've got number 1 all filled in and correct, so if you put any in different places, make sure you got them correct. Let's take a look at number 2. It says, how many different types of bonds do you think are present in the substances that you tested in this lab? All right, and so we've got 4 different categories, so we're going to say 4 different bonds. 2A says list the substances that you think have similar bond types. So hopefully you kind of realize that with the 4 categories, like everybody here is going to have one bond type. Okay, everybody who can dissolve but not conduct will have another bond type. Those that don't dissolve but still conduct have different bond type. And then last but not least, the ones that don't dissolve and don't conduct at all also have a different bond type. Okay, so when we take a look at 2B, it says what types of bonds, ionic, covalent, or metallic, do you think they are? And so now we have to think back to our pre-lab questions in which we investigated what type of atoms are in these different types of bonds. So for the first one here, okay, we've got metals and nonmetals. We have sodium, copper, and calcium, which are all on the left-hand side of the staircase and are metal atoms. And we're hooking them up with nonmetals such as chlorine, sulfur, and oxygen. And so a metal-nonmetal combination is what we call an ionic bond, right? And then in the next one, okay, we've got, if you take a look at the periodic table, all of these are found on the right-hand side, obviously except hydrogen. He's the poser on that left-hand side, but he is still a nonmetal. And so all of these guys are nonmetals, and so we call that covalent. This one here, made up of just metal atoms, well, that means then that is metallic. And then last but not least, this category here, again, if we take a look, we've got carbon, hydrogen, silicon, and oxygen are all nonmetals, so that one is covalent as well. Now, you might be saying, well, that's only 3 types of bonds, but we said 4 earlier. If you recall, last week, I believe, when we were looking at the electronegativity differences, we had something called polar covalent and non-polar covalent. And so those are 2 different types of covalent bonds. So if you take a look at our summary here, we have 2 different spots where there's covalent bonds. And we're going to find out next semester that the ones that do dissolve are able to be pulled apart by water, and those are called polar covalent. And the ones that are not able to dissolve are non-polar covalent. But again, we'll work with that more next semester, but just a heads up. So that's how we get the 4 different types of bonds. We have ionic, metallic, polar covalent, and non-polar covalent. So number 3 says, what do the substances that conduct electricity have in common? So that is these guys here conducts, and these guys here conducts. Hopefully you realized that both of those categories have metal atoms. So substances that can conduct electricity have metal atoms. Right? Remember, hold on. There we go. All right. Remember that metal atoms are positively charged, and electricity is a current or flow of electrons, and electrons are negatively charged. So naturally, the electricity will run through and be attracted to the metal atoms in these types of bonds. So the substances that can conduct electricity are the ones that have metal atoms in it. Now, number 4 kind of goes on to explain why ionic substances do not conduct electricity when they're solid, right? So when they were in the little dishes by themselves, you put this conductor in there and it did not conduct electricity at all. But when you dissolved them, they do conduct electricity. So the big difference there is that when it's a solid, the metal and the non-metal are attached. But when they are dissolved, the metal atom is no longer attached to the non-metal atom, and electricity can now be conducted. Okay, so number 4, we're going to say when dissolved, the metal atom is free to conduct electricity. Make sense? All right, so there we go. When dissolved, the metal atom is free to conduct electricity. Otherwise, if it's in a solid state and that metal atom is attached to the non-metal atom, it will not conduct electricity. All right. So number 5, explain why covalent compounds do not conduct electricity. Well, that's easy. Covalent compounds don't have metal atoms. And if you don't have a metal atom, you cannot conduct electricity. Okay, so covalent do not have metal atoms. Okay. Number 6, ionic substances have higher melting points than covalent ones. What does this tell you about the strength of ionic and covalent bonds? So basically it's asking which one is going to be stronger then. So if we think about it, if ionic substances have higher melting points than covalent ones, that means that the ionic bond is a strong bond. So ionic bond is stronger than covalent. Bam. All right, and last but not least, nope, not last but not least, hello, number 7. What do you think were the 2 substances that you saw tested in the demonstration during the warm-up before this lab? All right, so if you remember, I had 2 clear liquids, one that conducted electricity and one that did not. All right, and I will tell you a hint here. It is going to be one of the simplest combinations. So the one that did not conduct electricity was just plain water. And the other that did conduct electricity was salt water. So if I dissolved the salt in the water, it looks like there's nothing in it. But this one conducts electricity because the sodium and the chlorine ions are separate from each other. So it allows the metal atoms, those sodium metal atoms, to conduct electricity when it's dissolved in water. All right. Okay, now it's last but not least. Number 8, what are some physical properties that can help us determine what type of bond is holding a substance together? Well, these physical properties are going to be exactly what we were testing in the lab. So conductivity, solubility, and melting point. Okay, we can use these physical properties of substances to help us figure out what type of bond is holding a certain substance together. Okay, in fact, this lab here, I hope you paid attention because it's going to be the basis of a unknown investigative lab that you guys are going to do right after the unit test for this unit, which comes right before finals week. So during the week before finals week, we're going to have the unit test, and we're also going to do a big investigative lab where you guys are going to write your CERs, your last CERs for the semester. All right, so that's the You Light Up My Life questions. Now let's take a look at the WrapUp Notes sheet. Okay, kind of get all this info on one piece of paper, and remember you're going to put this in the notes section of your note sheet, of your notebook, and you're going to use this sheet to help you study for the quiz next class. The quiz next class is on ionic bonds, so knowing what makes up ionic bonds and why metals lose their electrons to nonmetals, and then how to figure out the charges and to crisscross the charges to figure out the formulas and write the names. All that stuff about ionic bonds is going to be on your quiz. And we'll also have a little section too about the different types of bonds and the different characteristics or properties of those substances. So let's take a look. For this purpose here, we're going to take a look at the main 3: metallic, ionic, and covalent. So we're going to lump polar and nonpolar covalent into one for this purpose. Okay. All right. So metallic bonds, remember, are made up of metals only. Right. So the type of atom is metals only. Metallic bonds. Are metallic bonds soluble? Remember, soluble means dissolved in water. That's a big no. Metals do not dissolve in water, and that is a really good thing. If you imagine your car being made out of metal, and if it dissolved in water, the first rainy day, you have no car, right? So it's a great thing that metals do not dissolve in water. Now, do metals conduct electricity? Absolutely. Right? They conduct electricity because they've got that giant web of electrons, that giant, remember the hot potato game with their electrons being all tangled up. And so those, electrons, if we add more electrons, they'll just zip right, across those metal atoms, because the metal atoms are basically, it's kind of like a wave or a big mosh pit, just really quickly pushing those electrons down the line. Okay. All right. So when it comes to melting points, metallic is super high melting points. Okay. In fact, we used aluminum foil, which is a metal, right, to place the substances on the hot plate because aluminum foil was not ever going to melt at the temperatures the hot plate can get. Okay, so metallic substances are super high melting points. All right, next we've got ionic substances. And remember, the types of atoms for ionic substances are both metals and nonmetals. So when we hook up atoms from both sides of the periodic table, we get an ionic bond. So are these guys soluble or able to dissolve in water? Absolutely yes. And can they conduct electricity? They can, only when dissolved. So we're going to write that. So yes, only when dissolved. Right? Otherwise, if they're by themselves, they cannot conduct electricity, because remember, the metal and the nonmetal are hooked up together And that nonmetal does not let the metal atom pass those electrons, down the line from the electric current. All right. So ionic substances, if you remember from the lab, the ionic substance that we were testing, salt, never melted. It wouldn't ever melt on our hot plates because we would need in like the thousands degrees in order to get to do that. So we're going to say high melting points. Okay. All right, not as high as metallic, but definitely high melting points, higher than we could ever achieve in the classroom setting. All right, and then last but not least, we've got covalent. And remember from our pre-lab, covalent is made up of non-metals only. Right? And these guys, well, some of them were soluble and some of them were not, right? So if you guys remember the sugars and the white powders, we were soluble, and we said that those were the polar covalent ones. Okay, so we're going to say yes for polar covalent, and then no for the non-polar covalent. So that was the wax and the sand. Okay, so covalent substances, some of them will dissolve and some of them will not. The ones that do dissolve are the polar covalent ones, and the ones that don't dissolve are the non-polar covalent ones. All right, and whether they're polar or non-polar, they are not going to conduct electricity at all. Okay, so whether they're solids or whether they're dissolved, they do not conduct electricity at all. Remember, because they don't have metal atoms, and metal atoms are going to be the key to conducting electricity. And then last but not least, for melting point, we're going to say low to medium melting points for covalent. We're going to find out that the non-polar ones are super low. That was the wax that we saw. And then the polar ones are kind of in the medium area. Okay, and they actually can be super high too, kind of depends. But for our case here, we're just going to say low to medium. All right, so that's the end of the notes for this wrap-up. Please make sure that you either tape or staple them into the notes section of your notebook, and then you guys can move on to the next thing on our agenda. We'll see you next class.